Hello viewers, thank you very much for watching Gibbs TV. Today's video will be looking at understanding the use of p-values and statistical significance. Let's get into it. This particular video is very important when you're about analyzing your data, okay? And also about to interpret the results of your regression output, your correlation analysis, or your analysis of variance. So please pay attention to this particular video and you will love it very well. Let's get into it. Now, what is a p-value? A p-value is a statistical measure that tells you how strongly evidence supports a claim. P-value is a statistical measure that helps scientists determine whether or not their results are significant. If the p-value is less than 0.05, then the evidence is said to be statistically significant. That is, if you are using the significant level to be 5%, that is 0.05, and the calculated or estimated p-value that's associated with your regression output is less than 0.05, then the evidence is said to be statistically significant, meaning that it is very unlikely that the results are due to chance. To appropriately apply the concept of p-value, you must know the difference between null hypothesis and alternate hypothesis. You'll get into it. P-value is used in hypothesis testing to figure out whether the null hypothesis can be rejected or not, okay? So once you run your regression analysis on your data, be it a linear regression or multiple regression, depending on the type of analysis that you want to do. So you use the p-value to evaluate the significant level of your coefficients in the model, okay? So in order to test your hypothesis, you compare the associated p-value from the output, okay, to that of the critical value or to that of the significant level. So in this case, if the p-value associated with the output level are all less than 0.05, if 0.05 is the standard significant level for the social science, if you are using that, okay, as the standard for evaluating the significant level, then if all these p-values are less than 0.05, then you reject the null hypothesis and accept the alternate hypothesis, all right? We will get into a typical example. So the decision rule for the p-value states that this number tells you how likely it is that your results occur by chance. If the p-value is low, that is less than 0.05, then you can reject the null hypothesis and say that your results are statistically significant. So once the p-value is less than or very low, it's less than 0.05, okay, then you can reject the null hypothesis and say that your results are statistically significant. In this case, you say that there is enough evidence to reject the null hypothesis and accept the alternate hypothesis. Then you restate the hypothesis the way that you frame it in your dissertation or in your thesis. It's very important. Areas p-values are used in data analysis. In statistics, p-values are commonly used in hypothesis testing for t-tests, for chi-square test, for regression analysis, and even ANOVA. And there are other statistical techniques that you can use p-values to even evaluate. So take note of that. A t-test is a type of statistical analysis used to compare the averages of two groups and determine if the differences between them are likely to arise from a random chance. So you can use p-value to evaluate the significance of the difference between the two groups. The regression analysis refers to a set of statistical processes for estimating the relationship among variables. So if you want to establish a significant relationship, okay, among steady variables, then you can go by a regression model or regression analysis. ANOVA is a statistical method in which variation in a set of observations is divided into distinct components. If you have more than 3 groups that you want to compare the variations among these groups, then you can use the ANOVA analysis to test the difference among these groups. About null alternate hypothesis. The null hypothesis is the default assumption that there is no difference between groups or no association between the steady variables. However, the alternate hypothesis states that there is a difference or an association among the variables. Let us assume that we want to examine the salary difference between women and men. Then our null hypothesis will state that there is no statistically significant difference between the salary of men and women in a given population. So the alternate hypothesis will be given as a negation to that of the null hypothesis. So in this case, the alternate hypothesis will be stated that there is a statistically significant difference between the salary of men and women in a given population. So in this case, if you want to evaluate this particular hypothesis, you need to understand your significant level. You need to identify the type of significant level that you're using, or the alpha level that you're using to evaluate the study model or the hypothesis. Very important to take note of that. Underline that. So to test or evaluate the above hypothesis, you will need to understand the concept of significant levels. Even in regression analysis, to evaluate the coefficients of the study variables and to also report for the proposed hypothesis in the regression estimate in your regression project or dissertation or thesis, you will need to understand the concept of significant level. So in either case, whether you are doing a t-test, ANOVA, or any type of regression analysis, okay, you would need a p-value as well as the significant level to determine the level of significance of the study variables in the model. So you need to understand the significant level as well. Very, very key to underline. The significant level is also known as the alpha level, okay? It is the level of assurance we want when conducting hypothesis testing. The level of assurance to have the claim that, you know, the variables are statistically significant in the model. So it's very important to underscore that significant level is key when you are doing regression analysis or you're doing interpretation of a study model. Note that the significant level must always be determined before the examination of the hypothesis testing. The common choices for significant levels are 1% significant level, alpha level, which is equivalent to 0.01, it's highly significant. Then we have the 0.05, that is the 5% significant level. Then we have the 0.10, that is the 10% significant level. So you have to determine the level of significance that you want to utilize to evaluate your study model. In statistics, the significant level is the evidentiary standard. So for researchers to successfully make the case that effect exists in a given population, a difference exists among the two groups in the population, or the sample must contain a sufficient amount of evidence, that will be determined by comparing the associated or the estimated p-values to that of the significant level that you have already determined. If you are going by 5% alpha level, that has been the standard for the social science level, 1% for the pure sciences, or if you are going by that level, okay, maybe 5%, then you have to always compare the associated p-value from your regression output to that of your significant level or the alpha level, that is the 5%, that's 0.05. A p-value indicates how believable the null hypothesis is, given the sample data. Specifically, assuming the null hypothesis is true, then the p-value tells us the probability of obtaining an effect at least as large as the one we actually observe in the sample data. If the p-value of hypothesis test is sufficiently low, then we can reject the null hypothesis. Specifically, when we conduct a hypothesis test, you must choose a significant level at the outset. Okay, as stated earlier, the common choices of the significant levels are the 0.01, that is 1%, the 0.05, that is the 5%, and the 0.10, that is the 10% significant levels or alpha levels. Therefore, if the p-value is less than our significant level, then we can reject the null hypothesis and accept the alternate hypothesis. Otherwise, if the p-value is equal or greater than our significant level, then we fail to reject the null hypothesis because there's enough evidence to say that, you know, the null hypothesis is true. That is, if the p-value is greater than the significant level, then you fail to reject the null hypothesis. Interesting p-values. Let's look at this chart. If you look at the first one, you have p-value greater than 0.10, meaning that you are evaluating the model at, let's say, 10% significant level. Okay, but since our p-value is greater than 0.10, all right, then it means that there is no evidence against the null hypothesis, meaning we fail to reject the null hypothesis, all right, because the variable or the model is not significant. In this case, the data appears consistent with the null hypothesis. But if the p-value falls between 0.05 and that of the 0.10, it means we have weak evidence against the null hypothesis in favor of the alternate hypothesis. Even though it's a bit greater than 0.05, but you can accept it, okay? You can accept the significant level at 10%, then it means there is some evidence, but it's weak because that level is very high. 10% is very high. But in the case where it falls between 0.01 and 0.05, there is a moderate evidence against the null hypothesis in favor of the alternate hypothesis. By a situation where it falls between 0.001 and that of 0.01, then we have a strong evidence because it's significant at 5%, it's also significant at 1%. So we have strong evidence against the null hypothesis in favor of the alternate hypothesis. Okay, so it means that we have to reject the null hypothesis and accept the alternate hypothesis. Lastly, for situation where the p-value is less than 0.001, we have very strong evidence against the null hypothesis in favor of the alternate hypothesis. Let's look at a typical regression output. Assuming you have your data and you run your regression in Excel or SPSS and you have this regression output. Okay, in this case, we have Google and Microsoft as our study variables. Okay, so if you look at it, these are the coefficients and these are the p-values. By inspection, you observe that only Google tend to be statistically significant at what? 5%. Because the p-value here is less than 0.05. The rest are all greater than 0.05. And they are also greater than 0.1. Therefore, the only variable that is significant in this regression model has statistical significant level is that of the Google. So if you have an hypothesis towards this Google, you reject the null hypothesis and accept the alternate hypothesis that this particular variable is significant. But if you are looking at the Microsoft, it is not significant. It means you fail to reject the hypothesis that is targeting the Microsoft, the MS. Thank you very much for subscribing to Gibbs TV, and I'll see you all in the next video. Thank you.